Welcome to Haxby Shed. Now normally my videos are about my home hobby machine shop, but I do throw in a few topics that I think might be interesting to people. And a few weeks ago I made a video about this. We'd only recently had it installed. It's a Givenergy solar and battery system, and it was installed in March of 2023, and it's now just the beginning of September 2023, and people had asked could I give an update, so this is the update. So I'll do a bit of talking to camera like this, which is what I like to do, but I'll have to go over to the PC and show you some PC screens and talk to those for the fine detail. It's really the only way I can do it. And after that we'll come back again for a few words to finish off. So just to recap what it is. So a Givenergy Gen 2 inverter, 5 kilowatt, and a Givenergy Gen 2 battery, 9.5 kilowatt hours. The panels are on the roof, east-west, and they have a peak generation capacity of 7 kilowatts. But because it's east-west and not south-facing, the maximum was forecast to be 5 kilowatts. Also, for the whole year, we were forecast to generate 5,000 kilowatt hours. Now what we've seen in practice is something better than that. So when iVolts did the quote for us, they used the MCS forecasting tool. MCS is a standard set up by the government. I won't go into it too much, but it's a kind of quality standard and process. And they were forecasting peak generation of 5 kilowatts, and we're seeing about 5.5 kilowatts. And in the year, we think we'll probably generate something like 5,500 kilowatt hours. So that's about 10% more than the forecast. Now, having said that, we didn't start at that level. It's taken 2 or 3 months to get to a stable situation. For one reason or another, I'll explain. So, as I said in the last video, when we first had the system installed, we had a problem with tripping, earth leakage tripping, and it was of no fault of this. It was simply that the circuit coming into this outbuilding has quite a lot of equipment on it, and it was operating fine for years, but just adding this extra bit of electronics and so on in there just tipped it over the threshold, and we were just getting a bit of earth leakage tripping, usually in the middle of the night. And so I had initially to disconnect this on a night just to stop that tripping. It wasn't affecting the whole house, it was just this connection to this outbuilding. And after a couple of weeks, iVolts came back and free of charge reconfigured the circuits and upgraded us, and we've not had any problems since then. But it did affect that first month, so we couldn't take that as a true reading. Now, over the period of operation, we've had 3 firmware updates for the inverter and 2 for the battery, and each of those has been an improvement in some way. But I think it was the first battery firmware update, which we did in May. When the battery had done the firmware update, it reboots and it got stuck. And I think you all know, if you've got a PC, you say to the PC, reboot, and sometimes it gets stuck and you have to turn it off at the wall. And that's what happened with this. So the red light came on, the battery just kind of stopped where it was, it went offline. On the side here there's a black button. If you keep it pressed for, I forget, some seconds, it restarts the battery, but that's like telling your computer to reset. It's a soft restart. So on your PC you just connect it off, turn it off at the wall, wouldn't you, to hard reset it. But you can't do that with this battery. There isn't like a master switch somewhere that cuts the power to the battery management system. It's supplied by its own battery and would probably stay in that condition for months till the battery went flat. So we were in contact with Givenergy, and I've found them to be really good. People have their own opinions. If you need a Givenergy engineer to come out to site, that can take a few weeks because they're short of engineers. But if it's just like help desk queries, I mean, I've emailed them and had a reply within 10 minutes. So from that point of view, I found them very good. So they asked me to try a couple of things. They didn't work. So, and here's a bit of advice. Don't do things on a Friday. That's always my mistake. Because if you get a hiccup, you've got to wait till the other side of the weekend. But I called iVolts on the Monday, and by the afternoon they came out and they had to take the cover off. Maybe I can throw in a picture at this point, but they disconnected the battery management board, so they had to physically take the power off it, plug it back in, it rebooted the battery, and we've not had any problems since. But again, iVolts were really quick there, and it was free. It was all part of their support service, from, you know, paid for when we bought the system, if you like. There was no charge for that. So yeah, anyway, the point there was we lost about 3 days in May because of the battery freezing. So May, we couldn't count May really. And then from the beginning, we found that the inverter, once the battery was charged, fully charged, the inverter would start to throttle back on the solar panel output. And I looked on Facebook, I'm in a Facebook owners group, and a few people were saying this, so it was a known problem. For whatever reason, once the battery was charged, the inverter was backing off. And it was different on different days depending on how you were using the battery. Now at the end of June there was a firmware update for the inverter which fixed that problem, that feature, let's say that feature. And before the end of June, before we had that firmware update, we were seeing maybe 90% of forecast for solar output. Once we'd done that update, we jumped from 90 to 110% of forecast. So, you know, we knew that the product was new. I think the Gen 2 inverter had only been out about 6 weeks before we got it. So we knew this was a possibility. These are really groundbreaking products, you know, shaping the market. So I knew that was potentially on a little bit of a curve. But by the end of June, that was fixed. And so it was really from July onwards that we can do proper comparisons. So I'll go through that, you know, on the PC. Over the next few minutes, I'll run through the system performance and how much we think it's saved and how much we think it's going to save us over the year. What you can see on screen here is a website I've found where you can put in your annual forecast, so let's say 5,000 kilowatt hours, and the site will tell you the profile. So if I just pick out July, 700 kilowatt hours. Now this is for just somewhere in the UK, maybe the middle of the UK averaged. I don't know. There isn't anywhere for you to put in your map location or your town or whatever. But if we now then take this and then compare it against actual generation, we'll get a good idea of how we're doing month by month. So I'll just click over to another app here. There's the graph that we've just looked at, and note July, 700 kilowatt hours of generation forecast for 5,000 kilowatt hours per year. So prediction, that's taken from that graph above. Okay, it shows 691 and not 700. I don't know exactly why, but go with it. And then I've put in our actual generation in kilowatt hours. Now in this period, let's see if I can highlight that. In this period up to the end of June, we were underperforming. We were only achieving 95, 88, 91% of what that graph said we should achieve. And it was at the end of June that we did the firmware update on the inverter, which stopped it from ramping down the solar output when the battery was full. And then we saw, you know, a really big jump in performance. So July and August, we're producing about 112, 114% of forecast based on that graph profile. And if we just move down here, we were told that okay, forget that. We were told there was a peak generation forecast of 5 kilowatts, I should say. And what we're saying is a peak generation of 5.5 kilowatts. And I get that from looking at the app. So when the sun is, you know, bright in the sky, dead overhead across my two panels, which are two rows of panels, which are east-west, we're seeing a peak of 5.5 kilowatts of generation. And if we look at that annually, we were told to expect 5,000 kilowatt hours, But actually from this I can take a new forecast and I can plug the figure into that profiling chart on that website, and it looks like we're going to get about 5,500 kilowatt hours. Now what does that mean in terms of output and saving money? Well, I've been tracking our bills from Octopus, and these figures are the import kilowatt hours which we're paying Octopus for, and these are the export kilowatt hours that they're paying us for. And when I look at the net, and a positive is where they're paying us net, you can see in July they paid us a credit of £24 near enough. But you can see back in May, and this is partly because we're underperforming because of that firmware update was needed, we actually paid them near enough £29. So you get an idea of how this works. And I think that website, I'll just scroll up to it here, that website is extremely useful, certainly if you're in the UK, and you know, you get the idea. And to know what this profile is month by month of forecast generation is really useful. It's worth saying a little about the firmware updates. Now, we've had 2 battery firmware updates and 3 inverter firmware updates, and Givenergy issue this update list. So we started on version 904, and then we went to 909, and then to 911 for the inverter. And these release notes are extremely useful, but they're very technical. And it would be much better if Givenergy would also, I'd like to keep this information, but if they would also explain what that means for the consumer. So this version 909 update, item 4, unlock full PV potential on 1 string if required, subject to voltage and current limits. I think that's what gave us the big jump in solar output, but you wouldn't know it by reading it. But nevertheless, I just thought I would share this with you because it's actually very useful, you know, background information. Well, I hope you found that information useful. Just a few things to add. It took us a few weeks to get onto the export tariff. So I held back some money from iVolts until they'd fixed that tripping problem. They gave me the paperwork pack, the MCS paperwork pack, within the 10 days that they're required to do. I then had to put in an application to Octopus for my export tariff, and then they've got a number of steps to go through. I'd already got a smart meter which could measure export, so that was fine. That was all in place, but it still took maybe 2-3 weeks to get onto the export tariff. To get onto the export tariff, you have to provide certain information to your energy retailer, and that would include the distribution network operator approval. So around here, that's Northern Power Grid, and they've got to say to, in my case, Octopus, yeah, we know about this system, and it's okay to connect it to the network to generate power and export power. And at that time, certainly, you would have to provide your installer's MCS certificate. And that was quite an easy process. You just upload those things on the application on the website when you apply for the export tariff. But Octopus have made an announcement recently, and as far as I understand it, what they're saying is they're no longer going to require the MCS certificate. Now that might seem a bit strange perhaps, but a lot of small installers will not have the resources to get MCS approval or an MCS certificate for the installer. There's a lot of sort of checking and auditing has to go on. They probably, perhaps need to employ another person to provide all the paperwork and so on. And therefore, there would have been a lot of people who've had solar panels that have not actually been able to get an export tariff because they hadn't got the MCS certificate. So I guess Octopus have taken a commercial decision or a risk decision, and they're saying now they will consider applicants without an MCS certificate. They might have to sign certain oaths or affidavits or whatever, but that's quite a big change, and that could allow you, if you've got panels and you don't have an MCS certificate, that might allow you to get an export tariff. Well, you can tell these few words are coming a bit later because I've changed my outfit, but I just wanted to tag on a couple of comments on the end that I thought of later. The first is, this inverter can connect by Wi-Fi or it can connect by Ethernet cable. And my advice is, if you can, connect via a physical Ethernet cable. And the reason for that is, this one is connected by cable, and I'm on a Facebook group and I can see quite a few comments about the Wi-Fi. So there are sometimes people have had difficulty connecting to the Wi-Fi. Not that there's a fault with it, it just can be a little problematic sometimes. Finger trouble, things like that. Also, it can be on the edge of the range. And if you do get a problem with, the data coming from this onto the Givenergy cloud, there might always be a suspicion, oh, is it the Wi-Fi? And I do mean Wi-Fi, I'm not talking about internet, I mean Wi-Fi. Some people talk about them as the same, but they're not. I'm just saying the radio link, Wi-Fi is the radio link from your inverter to the router. And then sometimes people change internet provider and then they can't get it to connect. And all that stuff you can remove by just having a physical cable, an Ethernet cable connected into your router. The second thing I would say is, not too long after we got ours, Givenergy brought out a new product which they call the all-in-one. Now that's AC coupled, so that means it sits on your house supply, if you like, and if you get a power failure, it switches over to the all-in-one and it powers the whole house. Now it's more expensive, it has bigger battery, it's more expensive. I think it's about £4 more expensive than this setup was. And although it's an attractive product and I think it'll suit a lot of people, it wouldn't have suited us. Partly because this is in an outbuilding which is, quite a long way from the house. So we'd have to put in quite a few extra cables to get this connected in fully into the house supply. There's a fairly big box, it's not quite this size, but I'm trying to show you a big box, which is the switchover unit, the gateway they call it. So that has to go somewhere. So add that all up, we wouldn't have bought that product because it wasn't quite right for us. So, and then I think, well, sorry, I'm going on a bit now, but then I think, well, I'm not bothered about power outages. I mean, what's the worst that can happen? I'm not working from home. I don't care if the internet goes down for a half an hour. We're not on an overhead line supply. We're just cabled into the ground. So our power outage risk isn't that great. We've got a freezer plugged in here. So there's just a few reasons. So I don't have buyer's remorse. I thought at first when that was coming out, oh my goodness, terrible timing, I should have bought that one. But when I look at it, I didn't want to pay the extra. I don't really have the space. I'm not worried about the odd power outage, half an hour, not even that, 10 minutes once a year. Anyway, well, I was just editing up this video and I thought of something else to say. And that's the question of how much do you charge the battery at night on the cheap rate? Now, in midsummer, the answer might be not at all. The sun's up by about 4:30, 5 o'clock, charges the battery maybe by 9 AM, and then during the day, the solar powers the house and any excess goes to export. But as the days get shorter, you find that when you've drawn off the amount to power the house, there's not enough left to fully charge the battery. Well, really, you want the battery to be at 100% full by the time the sun goes down, and so therefore progressively you increase the amount of battery charge at night. So I would make a rough guess, September I would say 25% charged at night, October maybe 50, November maybe 80, December and January probably 100%, and then you start to wind it back again as the days get longer. I mean, a kilowatt hour is a kilowatt hour. You're just trying to get the least cost for your electricity, that's all. I don't mess about with it on a day-by-day basis. I just kind of work on an average basis. Yeah, the other thing I can say, now that we're just in the beginning of October, in September we generated 500 kilowatt hours and it cost us £20. So that was our bill, our electricity bill for September, was £20. Anyway, now we jump back in time for the ending. Now, just before I finish, I've just a couple more things to say. You've heard me talk about Octopus. For me, they were the natural choice of energy retailer. They're very innovative. They've got a terrific range of smart tariffs. So you could look at them if you've got an electric car. They've got time of day tariffs, all sorts of things. And the Givenergy systems were designed with Octopus in mind. Now, I'm not saying they don't connect to anybody else's system, but they do have an open API and you can join the accounts together. And so you can have your Octopus account joined to your Givenergy account. And for some of the tariffs, the Givenergy system will automatically pull off your data, and you can see your data in your Givenergy app. Now, at the moment, that's just used for reporting, so you can see when you're using your energy, if you've avoided the expensive times and you try to get your energy into the cheaper times. It's not at the moment being used for decision making, as far as I understand it. So your inverter's not saying, oh, it's going to be more expensive tonight, so I'll charge the battery now more now. It's not got that logic built in yet, but I did get a kind of hint from the Givenergy service team that they might bring that in the future, and they might also bring in weather forecasting, so that if the weather forecast says it's going to be cloudy tomorrow, then the system might actually charge the battery more today, anticipating that. That might come. But anyway, my point is that if you can join your Octopus account to your Givenergy account, particularly if you're on a very smart tariff, which is perhaps a different charge rate every half hour, you don't want to be typing that into charts and graphs. The Givenergy system can pull that off from your Octopus account for not all tariffs, but for certain tariffs. Anyway, okay, so every Octopus customer gets a referral link, and if they persuade somebody to apply for an Octopus account, the person applying gets £50 off, and the referrer may possibly gets £50 off. And so I've put a link in the description. If you use that to join Octopus, we'll have £50 each. Now, of course, if you've got a friend who you'd like to give it to, we'll give it to your friend. But if you haven't got any friends, as I said before, I wouldn't mind, because you get the £50 off. The other thing I would say is that after my first video, iVolts approached me and said, if I could tell people, anybody that comes to iVolts for a quote and mentions Haxby Shed will get £100 off. Now, I'll get a little something as well. So if you do fancy, getting a quote from iVolts, they're based in Doncaster, Yorkshire, but I know they've done work in London, Liverpool, just to mention two places. I'm trying to show that they work over a wide area. I found them very responsive. When I made my first video, that there was nothing, that offer was not on the table. That came later. So yeah, it's up to you, of course. But if you do fancy a quote, ask iVolts. They'll mention me. They'll give you £100 off the quote. All the installers are very busy at the moment, so there's a chance that they'll say, look, we can't come and give you a quote because we can't schedule that in. But if they can, they will, and you'll get £100 off if you go ahead with them. Okay, I hope you found that useful. I might not make any more of these. It's not my main deal. That's the workshop. But still, I thought you might find it interesting, and I wanted to produce the update. So, thanks for watching.